Hey Geometry, today we're going to do 10.5 other angle relationships. There's 3 different theorems we're going to go over today, and we're going to re-practice them tomorrow or the next time we have class. The reason is it's a little hard to remember. I also have an announcement for the class in the Zoom, so make sure to come on time. I'll post the time and everything you need. Alright, so 10.5 other angle relationships. So let's start this off. There are 3 we're going to learn today. The first one is this. In a circle, where a chord and a tangent intersect. Now remember, a tangent is a line that only hits the circle once, and a chord is inside the circle, or both endpoints are inside the circle. So there's only one place they could intersect. Technically, the second place will be up here. But when a chord and a tangent intersect, let's say this angle over here, this little angle over here, is going to be half the arc measurement, which is over here. And let me put some letters A and B. And let me put C here so we know which one we're talking about. I need to put letters here too. Okay, so angle EBA is going to be half the size of the arc angle. So this should feel familiar. CA. This should feel familiar to the one that we did the other day, where if the angle's on the side of the corner, let's say the side of the circle, the angle here is going to be half the size of the arc measurement. Same thing in this situation. If it's a tangent and a chord hitting each other, then this angle here is going to be half the size as the arc over here. And we could think of it like this. Think about it. A straight line, the tangent is a straight line, forms 180 degrees. But a full circle is 360 degrees. So it makes sense that both this angle, 1, and this angle, 2, is going to add up to 180. And the arcs of a full circle have to add up to 360. So we could kind of tell that relationship here. But it's very similar to the one we did the other day. Okay? So the angle in here is going to be half the size as the arc. The other way you could say it, the arc is twice the size of the angle here. All right, we're going to go to the next theorem. So this one's kind of unique. It might be slightly confusing the first time around without any practice. Very important you have to show up to Zoom so we could practice out these type of problems. So let's say you have 2 intersecting chords, particularly not the diameters. So let's say like kind of obviously it's not the diameters, like that. Well, I'll call this angle 1. Let's put some letters A, B, C, D. All right. So the rule is if you have intersecting chords inside, so they're intersecting on the inside of the circle, that means that this angle is going to be the average of this arc CD and this arc BA. So it's going to be the average between these both arcs. So let's write that down as an equation or some algebraic list. Angle 1 is going to equal 1/2, or I should do it like this, arc AB plus arc CD divided by 2. When I say the average, you add them up and divide by 2. So this angle here, and remember, if this angle is 1, this angle is also, or I'm sure you say, angle 1 here should equal this angle here because of the vertical angles. So it doesn't matter which one you're thinking of. It could be this one or this one. But they're going to be the average of the size of the 2 arcs. Also, the other way is true. So let's call this angle 2. That would mean angle 2 is going to equal this part, AD, and the top part, BC, divided by 2. Okay? So these are weird formulas, more so than normal. Usually they're just like maybe you're doubled or maybe you cut in half. So these are slightly different. That's why we're going to spend 2 days on 10.5. But that's the basics of the second theorem. Let's go on to the third. So the last one we did is when the two lines intersected, the chords in particular, intersected inside a circle. In this case, we're going to have two lines that are intersecting outside the circle. Now, it could be like a tangent and a secant, or two secants, or well, not two tangents, I'll tell you that for sure, because we already have a rule for two tangents. Actually, no, it could be two tangents too. So this is how the rule is going to work. Let's say you have two lines that intersect on the outside of the circle. Move this so you can see everything. So angle 1 over here. Okay. Let's put some letters. A, B, C, D. Okay. For this one, this is not exactly average. It's something different. This arc, the outside arc, the arc farther away from the angle here, so the arc CD in this case, will always be the bigger arc. So the arc farther away from the angle will always be the bigger one. If that's true, and in that in mind, we're always going to do this. Angle 1 is going to equal the bigger minus the smaller, or the major minus the minor. So arc CD minus arc AB all over 2. Once again, it's going to be the major arc CD minus the minor arc BA. So angle 1, arc CD minus arc AB. Notice from last one, when it was inside, you would average it, so you would plus. So that's why it didn't matter which one's first or second. This one is very important to point out what is first and what is second. So angle 1, CD, the bigger arc, minus AB, the smaller arc, divided by 2. And I'm just going to reuse this rule for two other circles. So a real quick one. We're going to do a circle like this, where we have, let me erase this actually. Okay, the one that we just did is this top one. It was like A, B, C, D. We could have one. These are two secants, by the way. These are two secants. We could have one that has a tangent in the secant. So a tangent, remember, is a line that only hits it once. And the secant hits it twice. Something like this. This is angle 1. Let's call this A. Let's call the point in tangency B. Let's call this point C. So this one, again, was, sorry about the blurriness. Let's call this angle 1. Angle 1 equals arc CD minus arc AB, bigger minus smallest, divided by 2. This one is going to be arc. This one is the farther away arc that I just scribbled over. So this one, let me call this angle 2, I guess, because I don't want to repeat. Angle 2 is going to be the bigger arc, or the major arc, or the farther away arc, which is BC. So arc BC minus arc AB divided by 2. And last, if we have two tangents, so tangents like, it's a little hard to draw, but I guess like this. Okay, we got it. So two tangents, so A, B, and I have to put a point C so I'm able to tell the difference. We'll call this angle 3. So angle 3, it's still the same thing. The major arc is going to be minus the smaller arc. So major arc, which is this space over here, and to tell the difference from this one and this one, I had to use C. So arc BCA minus arc AB, which is the shorter one, divided by 2. So when the point is on inside the circle, so when the intersection's inside the circle, like here, we add. Maybe you twist your circle around. You see this, it looks like a plus sign. But when you inside the circle, you add. When it's outside the circle, like here or here or here, you subtract, okay? So we'll use this as practice as our homework today. And tomorrow I'll just give more examples of these because it's kind of hard to remember. All right, have a wonderful day, guys.